Number 1, you needed to find the range of this. This should look familiar because the last sharp right we did, it was the domain of these exact same points. So instead of finding your x values, listing them least to greatest without repeats, you're now doing the y values. So of all of these y values without repeats, it would be -5, -3, -2. Any questions on that one? For number 2, we need to find how many solutions would this equation have. We can start solving this to distribute and the terms. Once you've done that, you'll see that you have the same coefficient, so the order is switched. But because we're adding, that doesn't matter. So because it's the same on both sides, we would have infinitely many solutions. If you didn't see it from that point, you could keep going. Factor x on both sides. This is a true statement, so infinitely many solutions again. Do we have questions on that one? Number 3, you needed to solve this for x. So add x to both sides, divide everything by 3, and you would get y equals 1/3 x minus 1. Questions on that one? For number 4, we had proportions, so we need to cross multiply, distribute, start moving something. Doesn't have to be exactly what I did, but move one term to the other side and then the opposite to the other side. Divide, and you should get x equals -2. Questions on that one? For number 5, what is the domain of this graph? We're looking at furthest point to the left to furthest point to the right. And it can be written either of these ways. So the first way is your set builder notation from -3 to +1. And the other one is the same thing, but in interval notation. These are both included. So you would have square brackets or the equal to. Questions on those? Did anyone have kind of or just math questions that they wanted to go over? Had a question about? Before we go to lunch, we'll have time to do one problem from the notes. Make sure you have your notes up in front of you. It looks something like so far, we've talked about factoring by GCF, by grouping using GCF, and difference of squares. What we do here is a little different because this has specific rules we need to follow. So first, these need to be trinomial, so 3 terms. GCF could really be any amount of terms, more than 1. Mainly 2, but more than 1. Grouping has to be 4. Difference of squares has to be 2. Trinomials has to be 3. This way has to be 3. The number in front of x has to be 1. X squared, I should say. So if the number in front of x squared is 1, we're going to do it this way. We are looking for 2 numbers that multiply to be c, whatever the last number is. And of those numbers that multiply to be c, we need to find 2 that would add or subtract to be c. So let's actually work this out. For number 1, we need two numbers that we multiply to be 12, but add to be 7. You may know what that is already. It's okay if you don't. Let's think of some factors of 12. What times what would give you 12? Now, from those factors, if we were to add them together, which would give us 7?
3 and 4.
You say positive 3 and positive 4 would give me 7. I'm going to set this up in factor form, so my two sets of parentheses. Whatever my variable is here is going to be my variable in both of these, so x and x. Then we're going to put plus 3 and plus 4. Does not matter if I put plus 3 here or here. That order does not matter. To make sure this works, I'm going to distribute it back out, and then the bell will probably ring. This would be our final answer, but now I'm going to check our work. So x times x would give us x squared. X times 4 would give us 3 times x would give us 3x. And 3 times 4 would give us 12. If we add our like terms together, we get x squared plus 7x. Going back to check your work is a really good way to see that you did this right. Especially when we get into some of the negative factors, because you may put the negative with the wrong thing, and when you multiply it back out, you don't get the right thing. Do we have any questions on this so far?
Guys, it's kind of like a Rubik's Cube.
For number 2, we need to find two numbers that multiply to be 20, but add to be 9. Again, if you know what those numbers are right away, that's great. If not, we can do our factor tree and look from there. What are some factors of 20? 1 and 20. 10. 4, 5, and 4. Of those, if we were to add them together, which would give us 9? 5 and 4. And that would be a positive 5 and a positive 4. So our factors would be n plus 4 and plus 5. If you are not sure about the factors, start dividing in your calculator. 20 divided by 1, 20 divided by 2, divided by 3, that wouldn't work, 4, 5. Keep going until you find all the numbers and the last numbers are either the same or get really close together and there couldn't be anything in between. Besides this major rule, multiply to be C, add up to be B, there are other things in place. So if we have a positive and a positive, that should tell you that the two factors you get will also have a positive and a positive. That's going to change as we go through some of these negatives. So let's do number 6, and then we'll change to some others. We need two numbers that multiply to be 1, but add to be 2. What times what gives you 1? 1 times itself. That is really it. There's nothing else. And then 1 plus 1 will give you 2, so that works. So this would be y plus 1, y plus 1. You could simplify this because these are the exact same. We can say this is the same thing as y plus 1 squared. Both of those answers would be acceptable. On those ones we've done so far, do we have any questions on those? Let's move on to number 7. So now we have a positive and a negative. We're going to just deal with the factors of 18 and then worry about the negatives afterwards. We need two numbers that multiply to be negative 18 and then add to be 3. So just thinking about the positive 18, what are some factors of 18? 1 and 18, 9 and 2. Are there any others? 3 and 6. Now, because 18 is negative, the only way we would multiply to get a negative is if one of our numbers is negative. So we need to think about which set of pairs could we add or subtract together to get 3 when one of them is negative. You can start to eliminate some of these. If I put negative 1 plus 18 or 1 minus 18, it doesn't matter how I put that, that's not going to give me 3. If I put positive 2 minus 9 or negative 2 plus 9, no matter how I do that, that's also not going to give me 3. So I can look at 3 and 6. Which one of those could I make negative to give me a positive 3? Negative 3. So we would have n minus 3 and n plus 6. I'm going to distribute this back out to make sure it works. So n times n would give us n squared. N times 6 would give us 6n. Negative 3 times n would give us negative 3n. And negative 3 times 6 would give us negative 18. So n squared plus 3n minus 18. So that works. Had we put negative 6 and positive 3, we would have got the wrong answer. We would have got negative 3n instead of positive 3. So if we have a positive, our two factors should be positive. If we have a positive, negative, one of our answer choices or factors is going to be negative, and the smaller number of the two is going to be the one that's negative. Before we move on, do we have any questions on 7? Let's do number 10. Some of the smaller numbers, you may be able to think about the factors faster, or they have less. Ones like 54, you may need to write those down because there may be a lot. So factors of 54, what are they? 9 and 6. Say it again. 1 and 54. This would be if you're not sure, divide it by 2, see if that works. Divide it by 3, see if that works. By 4, 5 wouldn't work because it doesn't end in 5 or 0. 6 you already have up there. 6 and 9 are probably the last. So 2 or 3 is it divisible by either of those? And 3 or no?
Yeah.
3 and
Yeah, 8.
now. If you were process of elimination, if you found 9 and 6 first, would you need to find the rest? Not necessarily. Especially if you know that this is a negative 54. One of these are going to be negative. To get 3, no way I make one of those negative and I get 3 or these or these. So it would have to be 9 and 6. So we could have stopped there and not wrote out the rest. But sometimes it is helpful to eliminate out what you don't need. Great. And then, as I said before, 1 is going to be negative. Whichever is smaller will be your negative. So your 6 would be your negative, while 9 is positive. So we have S plus 9 and S minus 6. I'm making different colors, so we know that's an S, not a 5. Questions on number 10? Before we do some more examples on these, there's a couple on the back that I want us to do together. So on the back, we're going to do number 7 and 8. So now we have a case where it is negative positive instead of what we just had, which was positive negative. So the rule is going to be different again. Some factors of 8, we need 2 numbers that multiply to be 8, but add or subtract to be 6. What are some factors of 8? 2 and 4, 1 and 8. Of those, let me write these down. In order to multiply to get a positive, we either both of them need to be positive or both need to be negative. Because the number we need to add or subtract to is negative, both of these will need to be negative. So of these sets of factors, which ones could we make both negative that would subtract to be negative 6? 2 and 4. Because negative 2 times negative 4 is positive 8, and negative 2 minus 4 is negative 6. So we would have y minus 2 and y minus 4. I'm going to distribute this back out just to make sure it works. Y times y will give us y squared. Y times negative 4 is negative 4y. Negative 2 times y is negative 2y. Negative 2 times negative 4 is positive 8. So y squared minus 6y plus 8 works. If we had made them both positive, then we would get the 8, but we wouldn't get a negative 6. Or if we made one positive, one negative, we would get a negative 8 and some other number. But rule of thumb for negative positive, both factors are going to be negative. Do you have any questions on this one before we do another? For number 8, what are 2 numbers that multiply to be 28, but add or subtract to be negative 11? Check your factors, start dividing. 2 and 14. 2 and 14 would give you 28. Would that give you 11? No. So 2 and 14 is out. 7 and 4. And if we make them both negative, we would get negative 11. So x minus 7, x minus 4. Do you have any questions on that one? We're just going to do a couple more, then I'm going to let you do some on your own. So flip back over to the front. And we're going to do 15 and 16. So just to recap, positive means both of our factors are positive. Positive negative means one is negative and the smaller number is the negative. Negative positive means both are negative. So negative will be whatever's left. So for 15, if we were looking for what factors of 63, multiply and then add or subtract to be negative 2. What are some factors of 63? 1 and 63. Twenty-one and 3. Okay. This is a negative, so one of these has to be negative. Which ordered pairs could we use to get negative 2? 7 and 9. And to make it negative 2, our 9 would need to be negative. So if we have a negative positive, one of them is going to be negative, and the bigger number is going to be the negative one. Now next, b plus 7 and b minus 9. I'm going to distribute this to make sure it works. B times b would give us b squared. B times negative 9 would be negative 9b. 7 times b would be positive 7b. 7 times negative 9 would be negative 63. Combine your like terms, we have b squared minus 2b minus 63. So that works. Before we do our last one, what questions do we have on that? For 16, what are two numbers that multiply to be negative 3, but add to be negative 2? What times what would give you 3? 1 and 3, and that's it. So using our rule, 1 is going to be negative, the bigger number is going to be negative, so we have a minus 3 and a plus 1. So if you know your factors, this becomes a little easier. If you don't, you just have to find what they are first. Anyone have any questions in general on this before I let you try some on your own? on the front, work through as many as you can. If you finish before we go over the remaining, start on the back, go through as many of those as you can. And then we'll go over the front page. We'll be walking around. If you have any questions, let us know if you need our help. I'm just going to read off the factors. If you didn't get to a certain one, write it down, yes, but go back and make sure that you get how we got those answers. Number 3, h plus 3, h plus 6. Number 4, a plus 6, a plus 4. 5, k plus 5, k plus 1. Remember, this is on Canvas too. 4, we did 7. Number 8, x plus 4, x minus 2. 9, g plus 5, g minus 2. We did 10. 11, c plus 9, c minus 5. 12, n plus 7, n minus 4. 13, x plus 10, x minus 3. 14, a plus 6, a minus 1. We did 15 and 16. 17, k minus 16, k plus 4. And then 18, x minus 18, x plus 4. Too high. No. If you have this over here, that's fine. If any of this did not make sense, please come see me after school today or Thursday. I don't have office hours tomorrow. If you want to go through Khan Academy or Delta Math together, come after school, before school. If you haven't done your Khan Academy, make sure you do that. Email me whenever you do that so that I can update your grades. If you haven't finished your test, come see me after school today or Thursday. And then if you want to retest, you can start coming to see me after school or in the morning to start that process.